I'm Neerumalla. I work as a security software engineer at Microsoft. I worked on SQL Server for 4 years. I was part of the SQL pen test team when we shipped SQL Server 2005. When I was working on SQL Server 2005, one of the tasks that I worked on was finding SQL injection issues inside SQL Server. So when I was working on that, I came across some code patterns where the code looked safe for SQL injections, but in some conditions, I could still either modify the developer intended SQL statement, or I could inject additional SQL statements. So I'm going to discuss about these new vulnerability issues, and then I'm going to provide some mitigations for that. I'll be using T-SQL code for most of my examples here. So I'll start up discussing some of the best practices that you need to use to prepare dynamic SQL statements for SQL Server. And then I'll take an example which is vulnerable to SQL injection issues. We'll fix it with those concepts. And in the second part, I'll show you some of the variants of the same code which is vulnerable to these new issues. Okay, go. Best practices for constructing dynamic SQL. In SQL Server, the way you delimit SQL object names or SQL identifiers, when I say SQL identifiers, I'm referring to SQL object names like table names, column names, and log names and others. The way you delimit them is different from the way you delimit string data. You don't need to worry about delimiting SQL object names unless you're using keywords for the object names, or if you have any special characters in the object names. In SQL Server, you can either use double quotes or you can use square brackets to delimit these. But the problem with double quotes is it's dependent on connection-based setting called quote identifier. If this setting is on, then you can use double quotes. But if the setting is off, then you cannot use it. That's why you can't rely on this in all the cases. And never use single quotes to delimit SQL object names. Always use square brackets. If you are using square brackets as the delimiters, then you need to be careful about how you escape these delimiters. In SQL Server, it's pretty simple. If you're using any delimiter character, you just need to double that up. So if you're using square brackets, you just need to double up right square brackets, not left one, but always double up right square bracket. Okay, here's the examples. If you look here, I'm trying to create a table with name employee with some special characters. You see here I have double quotes, left square bracket, right square bracket, single quote, and exclamation mark. But here in this statement, I'm using square brackets as the delimiters. When I'm using square brackets as the delimiters, I'm only doubling up right square bracket. I'm not touching anything with the other ones. So when SQL Server looks at this statement, it knows that this is the beginning of SQL object name and this is the end. Whenever it sees two consecutive right square brackets, it treats it as part of the SQL object name. So when the identifier is off, this statement is going to work. But if you try to use double quotes as the delimiters, then it's going to fail, mainly because this setting is off. When you turn on the setting, both the delimiters, you can use both of them. So again, you need to worry about delimiters only when you have special characters or when you're using keywords as your object name. Delimiting string data. These are like constant strings. Again, even here, you can either use double quotes or you can use single quotes. Just like before, double quotes is based on this connection-based setting. So if the setting is off, then you cannot, in this case, actually, you can use them as the delimiters. If it is on, then you cannot use it. But you can always use single quotes as the delimiters for string data. And any occurrences of single quotes within the string data, you just need to double them up. Again, here's the example. I have the setting on here. When I have the setting here, I'm trying to insert this mystery man with some characters. When I use double quotes, I'm only doubling up these double quotes. And because this setting is on, this is going to fail. You can see here. But if you use single quotes, in both the scenario where this setting is on or off, it's going to work. So if you know the object names or if you know the strings beforehand, then you know what to do. You know what delimiters you need to use, and you know what characters you need to escape. But if you're constructing dynamic SQL statements where you're accepting the data from the end user, then you need some automatic ways to do this. In T-SQL, SQL Server provides two functions which will be of use to us. The first one is quote name function. Quote name function is mainly designed for preparing delimited identifiers. It's pretty simple. It adds the beginning delimiter and it also adds the ending delimiter. And any occurrences of the delimiting character, it doubles them up. So if you look at the body of this sp underscore drop login store proc, you will see the way the dynamic SQL statement is being formed here. Drop login plus quote name login name. Because it's mainly designed for SQL object names, the default character to quote name is square brackets. So this is what, if you pass dbreader, this is the statement that gets formed. Drop login, left square bracket, dbreader, right square bracket. If you pass any square brackets inside it, quote name is going to double the occurrences of right square brackets, but it doesn't do anything with the left square bracket. So simple. You can also use quote name function to delimit string data. If you look at the body of this sp underscore password store proc, you will see the SQL statements that are being formed here. Alter login plus quote name, because login name is a SQL identifier. The default, we are using square brackets there. With password, because password is a string data, we are using quote name function with single quote character. See here, this one, those are the delimiters to represent string data. And because we have two single quotes here, basically it's a single quote character. So if you pass password as the password for this, the statement that gets formed is alter login, dbreader, look at the delimiters with password equals to single quote, that's the beginning delimiter, and this is the ending delimiter, and that's the password. But if you have any single quotes within the password, the quote name is going to double them up. So you can use quote name function to delimit SQL identifiers, or you can also use it on string data. But because quote name function is mainly designed for SQL identifiers, it has a restriction of sysname, which is nvachar 128 characters in SQL Server. So if you pass anything greater than 128 characters to this function, it's going to return null. That's when you need to use replace function. Replace function, as it states, it's very simple. It takes 3 arguments, the character string. The second one is the find string. And the third one is what you want to replace with. So it finds all the occurrences of the find string and replaces them with the third argument. And there is no limitation on the strings. Again, escaping single quotes with replace. If you look at the SQL statement that's being formed here, create database, quote name, DB name, because DB name is a SQL identifier. On file name, replace function doesn't add the beginning and ending delimiters. It only replaces the occurrences of any characters. So in this case, you need to manually add the delimiters, beginning delimiter and ending delimiter, and see here, replace single quotes with 2 single quotes. These are the delimiters for string data, and when you have 2 single quotes within the delimiters, actually you're referring to 1 single quote. So if you pass c:\, db single quote file, then this is the statement that gets formed here. See the way. Quote name versus replace. Quote name works for, just to highlight the points, quote name works only for character strings of length 128 characters. And replace function doesn't have any limitations. So always use quote name function to prepare delimited identifiers. Quote name is nothing but beginning delimiter, replace function with the ending delimiter. That's all. That's the difference between these 2 functions. Now that we know how to form a good SQL statements, Let's look at this example. I have the stored proc sp underscore set password, which takes 3 arguments: username, old password, new password, and I have a local variable add command, and then I'm constructing the dynamic SQL statement here. Update users, set password equals to single quote, here's the new password, where username equals to, again, username and password equals to the old password. What's the problem with this one? None of the variables are validated for data. So if it's a first order SQL injection issue. So if I pass something like single quote, semicolon, I can inject any SQL code here. Everybody knows this problem, right? Let's fix it using code name function. Update users, set password equals to, because code name is going to add the beginning and ending delimiters, and you're going to replace all the occurrences of single quotes with 2 single quotes, where username equals to code name, again username, and password equals to code name. So now we mitigated first order SQL injection issues in this code. We can also use replace function to do the same thing, to achieve the same thing. Update users, set password equals to single quote, replace all the occurrences of single quotes with 2 single quotes, followed by ending delimiter, where username, same thing here for all the variables. So just to highlight the key points till now, if you're preparing a delimiter infer, develop all the occurrences of right square brackets and add the beginning left square bracket and ending right square bracket as the delimiters. For string data, always develop the occurrences of single quotes within the string data and use the single quotes as the delimiters. We can use quote name or replace function, and the only difference between these 2 functions is quote name adds the delimiters and replace function doesn't. So, any questions so far? Is there any other problem with this code? The one that we just fixed? What about the original code? Can you all look at the code? Is there any problem with this one? So I have sp underscore set password, which takes 3 arguments: username, old, new password, and we know that there exists first order SQL injection issue here, right? Then none of the data variables are validated. So, but there is one more problem in this code. If you observe carefully, if you look carefully, all the arguments are of length 25 characters, but your command variable is declared as varchar 100 characters. If somebody passes all 25 characters for all the variables, then the SQL statement gets truncated. Some database products generate error, and some database products do not generate error. SQL Server, as of today, does not generate any errors on this one. It silently truncates the data. So what happens in this particular example? So in this particular example, if you pass 25 characters for all the variables, the command is going to get truncated right after AND operator. If you see here, I passed 25 characters as the new password, 25 characters for the username, and after the AND, because it can only hold 100 characters, the command gets truncated. In this particular example, it's not a valid SQL statement because it's not complete. So SQL